movie with Ashley Sean.
I know.
So hot.
Like, how could you let go of Ashley?
I don't know. They were perfect.
Oh, hi there. Didn't see you there.
Well, we'll talk to you about amplitude and velocity.
There are two different types of waves, longitudinal and transverse. Examples of longitudinal waves are earthquakes, springs, and sound waves.
An example of a transverse wave is a light wave. Amplitude is defined as the maximum displacement of a wave from its undisturbed position.
In a transverse wave, amplitude is the measure from rest to crest or rest to trough.
Here are some examples of different amplitudes of transverse waves.
These changes in amplitude are caused by changes in energy of the wave. The more energy in the wave, the bigger the amplitude.
Though a pressure time graph, which shows amplitude, since amplitude is fluctuations above or below atmospheric pressure, shows that a longitudinal wave looks like a transverse wave, it does not.
At longitudinal waves, the molecules move parallel to the energy, while at transverse waves, molecules move perpendicular to the energy. Therefore, a longitudinal wave looks more like this.
Changes in the darkness of the condensations and rarefactions indicate changes in amplitude.
On PHET, that is P-H-E-T, this was demonstrated very well. See the clip of sound waves changing amplitude.
As with transverse waves, changes in amplitude are caused by changes in energy. Just like with a stereo speaker, it takes more electrical energy to make the amplitude bigger or the sound louder.
Okay, now we will look at the velocity of waves.
Velocity is the distance traveled by a given point on the wave, such as the crest, in a given time interval.
For example, if a wave moves a distance of 20 meters in 10 seconds, what would the velocity be? Well, it would be 2 meters per second. See, we can use the equation distance over time, or we can use wavelength times frequency.
There is one factor that affects the velocity of sound waves, and that is the medium they're traveling through.
For example, if you increase the density, which is the degree of compactness of a substance of a medium, the velocity also increases.
In addition, if you increase the rigidity, the physical property of being stiff and resisting bending, in the medium, the velocity will also increase.
Another two equations that you can use are the bulk modulus and the elastic modulus.
The bulk modulus of a substance measures the substance's resistance to uniform compression, newtons per meter squared.
You can use the equation velocity equals the square root of bulk modulus divided by p, where p is the density.
Here's a word example. Earthquakes at fault line and Earth's crust create seismic waves, which are longitudinal waves. The longitudinal waves have a speed of about 7 kilometers per second. Estimate the average bulk modulus of Earth's crust, given that the density of a rock is about 2,800 kilograms per meters cubed. See our work to find out how to do that.
Okay. And in addition, you can also use the elastic modulus, or also called Young's modulus for some smart scientists, which is a measure of the stiffness of an elastic material and is a quantity used to characterize materials.
The equation used for wavelength is tensile stress over tensile strain.
Stress is the restoring force caused due to the deformation divided by the area to which the force is applied.
Strain is the ratio of the change caused by the stress to the original state of the object.
And you can calculate wave speed by using the equation V equals the square root of Young modulus divided by density, or the Young modulus equals wave speed squared times density.